Measurement systems. The first kind of thing we're going to look at measuring would be length. Humans have been measuring lengths for a long time. Common lengths that we measure in this country, the United States, where we're very fond of measuring things in, say, feet or inches for small measurements. And for longer measurements, we like miles. And this is part of what's called the imperial system. We used to call it the English system, but the English don't use it. So we're going to call this imperial measurements. And we're one of the few countries, maybe down to one or two countries in the world that use this system of measurement. Most of the rest of the world uses metric measurement, like meters, centimeters, kilometers, kilometers. So we're just going to get used to the relationship between these two. The more fun part is really just using the metric system. And so most of what we're going to do with this week is practice using the metric system. Aside from length, we measure volumes. And in volumes, we will often do, say, quarts, gallons, maybe, liquid ounces. These are, again, imperial units. Versus the metric system is going to use liters, liters, or instead of ounces, we might use milliliters. And then we have mass or weight, which are really two different things. And in the imperial system, we'll often do pounds, which is a weight, and weight ounces, which are different from liquid ounces, tons. Versus metric units, which are mass. I'm going to write mass in blue instead, green. So a mass unit in the metric system, the common would be a kilogram. Instead of ounces, we'll use grams. And we're not going to worry about tons, although there is a metric ton. Here. So our metric units. Now, this is important. There is a difference between mass and weight. And the difference between mass and weight is, again, pounds is a measure of weight, and weight takes into account gravity. And because of gravity, there'll be a difference on Earth versus the moon, for example. And there'll even be elevation differences. So if you weighed yourself at the top of a tall mountain, you're going to weigh slightly less than if you weighed yourself down around sea level, because you're further from the mass, you know, the net mass of the Earth that's pulling on you, which causes weight. Mass is the stuff that you're made of, and pounds does not measure that. So again, you would have a slightly different measurement in pounds if you weigh yourself at sea level versus if you weigh yourself at the top of a mountain, a tall mountain, or if you were weighed on the moon, you would feel much lighter. But your mass would be the same. And kilograms is a measure of mass. To get weight in the metric system, metric weight is typically measured in newtons, which takes a kilogram mass and combines it with the force due to gravity. So really, although we talk about pounds versus kilograms, pounds are related to newtons, which takes into account gravity. Versus kilograms on their own is just mass. So the kilograms I have on Earth are exactly the same as my kilograms on the moon. That does not change. So again, there's a little bit of miscommunication that we have in the world today when we try to relate pounds and kilograms. Kilograms are a measure of mass, not weight. Pounds are a measure of weight, not mass. All right, so we have length, volume, mass, and then temperature. And for temperature, Fahrenheit is the imperial unit of temperature, which most of the world does not use. The rest of the world uses Celsius, which is the metric version of temperature. So some common things that you ought to know about these different measurements. Let's start in reverse and go back. As far as temperature goes, I would recommend just some common temperatures. Let's look at Celsius versus Fahrenheit. So for example, 0 degrees Celsius or 32 degrees Fahrenheit is when water freezes. And technically it's at sea level. It's going to be a slightly different freezing point if you're above or below sea level. Let's see, what is another common one? 100 degrees, I'm going to leave a little space there. So 212 degrees Fahrenheit is when water boils. And again, that is sea level. Most of us are close enough to sea level that it's good enough. So 212 degrees Fahrenheit versus 100. And some numbers in between would be human body temperature. And human body temperature in Fahrenheit, we believe to be on average 98.6 degrees Fahrenheit, and that turns out to be 37 degrees Celsius. Those two numbers match up just right. Another good one to know would be, say, room temperature. And room temperature is going to be around 20, 21 degrees Celsius. I'm going to call it 20, or about 70, 72 degrees Fahrenheit. And these guys are approximate there, not exact. If we were to take these 2 points in common, we can use them to build a conversion equation where the Fahrenheit temperature is equal to 9/5 Celsius plus 32. You've probably seen that before. So let's double check my estimate of room temperature with a calculator on that. So if I estimate comfortable room temperature for humans to be about 20 degrees Celsius, then we multiply that by 9/5 and then add 32 to that. Okay, that gives us 68. I was a little bit. 169, 22 is more like 72. Okay, I was really off on those two right there. So let's say about 22 goes with 72. Again, it's not exact, it's approximate. So these are some good numbers to be familiar with. In particular, the water freezes 0 degrees Celsius, 32 Fahrenheit. Water boils 100 degrees Celsius, 212 Fahrenheit. And if you were to be measured with for your body temperature with a Celsius thermometer, you would come out, if you're normal and healthy, around 37 degrees Celsius. All right, temperature. Let's see, going back, let's look at mass. So it's mass and weight kind of mixed up together. Unfortunate, but true. Common things here, about 2.2 pounds is 1 kilogram. That's a good one to remember. And then liquid. This one I often forget, so I'm going to look it up. Recollection is a quart is in 0.94 liters. .946 liters. Going the other way, this would tell me 1 liter would be about 1.057 quarts. I think I'll take that version. So that's what Google's telling underneath here. If we put a 1 there, we get, oops, what happened? Okay. 1.057. So 1.057 quarts. It's equal to 1 liter. And really all we need is one connection from imperial to metric. And length. 2.5 for the other way. Imperial first. 1 inch is about 2.54 centimeters. And each of these aren't exact, they're approximate. And you may be familiar with some other ones for conversions, and we'll use conversion fractions to make those. Now, the metric system, you're always going to have a base unit. And then there's some common prefixes going either way with the metric system. And so going off to the smaller side, deci is the next one. And deci would be 1/10 of whatever the base is. And then centi would be 100th of whatever the base is. And then milli would be 1,000 of whatever the base is. So given one base unit. And a base unit is going to be something like grams. Meters, meters. And then heading the other way, we've got deca, and we have hecto, we have kilo, and they head out in the other direction. So a deca is 10 times the base unit, and a hecto is 100 times the base unit. And a kilo is 1,000 times the base unit. So it's really just a matter of shifting the decimal point when you're switching from one metric unit to another. Now, that's not the case for our standard system, because we have some crazy things, like there are 12 inches in 1 foot, and there are 5,280 feet in a mile. There's some crazy numbers. Other crazy ones like liquid measurement. There are 2 cups in a pint. And there are 2 pints in a quart. And 2 doesn't, stay, then we have 4 quarts in a gallon. So we have just some crazy conversions that we have to deal with in the imperial system. Kind of an arbitrary system in that regard. Let's see what we're missing. Weight, we have I guess it's weight, 16 ounces. And these are weight ounces. It's equal to 1 pound. 2,000 pounds a ton. And I guess I should add ounces in here. There are 8 ounces. And these are liquid ounces, which are not the same as weight ounces in 1 cup. So kind of crazy numbers. 2s and 4s and 8s aren't too bad, but it's not as nice as 10s and tenths. So the metric system works really well with our number system, whereas the imperial system does not. That's it on metric basics. Basics.